you can tell, I think, Nathaniel, you might have missed out on the deadline for taking this particular antidote. Sorry, buddy. Anyway, so let's talk a little bit about... Greetings, I'm Dr. Poythress. I'm a biology professor here at Houghton University, and today I'm here to talk to you about this little board game, Antidote, which is a 2 to 7 player board game first released in 2013 by Bellwether Games and designed by Dennis Hoyle. So as you can tell, I think, Nathaniel, you might have missed out on the deadline for taking this particular antidote. Sorry, buddy. Anyway, so let's talk a little bit about how this game is played, and then we'll look at the science behind it. So Antidote is a kind of a party social deduction kind of game. So the premise behind the game is pretty wild. Essentially, you and a bunch of lab members, in this case, I've got the game set up for 3, but you could play with up to 7, are in a lab, and suddenly a glass vial of compound X is broken and releases a potent airborne toxin into the air, and you have 30 minutes to take the antidote or figure out what is the antidote and then take it. So you have a bunch of different options for the potential antidotes. There are a bunch of different colored kinds of things. There's green, there's red, there's pink, there's teal, and at the end of the game you'll be left with one card which represents what you think is the antidote, and you will then take that antidote. And then at the end of the game, the real antidote gets revealed, and everybody kind of compares and says, well, did we take the right thing or did we not take the right thing? And you either live or die, I guess. So kind of a gloomy outcome there. So how do we get to that point? So you'll start with a deck of cards, a handful of cards that look a little bit like this. And so you'll notice that there are your different colored potential antidotes as well as a number. I'll talk more about these numbers up here in a little bit, whether 7, 4, and so on and so forth. You also have a couple of cards, usually with an X. So these cards represent things that are not the antidote. So you know this right off the bat. So I would know in this case that this green one and this reddish orange one are not the antidote. And so that means that I could easily or safely get rid of these red ones, these red cards here, because they're definitely not the antidote. So on your turn then, you can do one of 3 things. So you can either discard a card in front of you, in which case everybody else has to discard a card too. So I could discard this red card and put it down in front of me just like that. Or if I discard one of these X cards, it gets discarded upside down just like that. And so over the course of the game, as different people choose to discard cards, you'll be getting rid of more and more of your cards until you're left with only one. So that's one thing you can do. You can also do what's called trade research. So all of the actions that you can do are helpfully shown on this little lab assistant card. So you can trade research, which means you can trade a card, you can agree to trade a single card with one other player, or you can pass a card, you can get everybody pass cards either to the right or to the left, depending on what you say. So as you go along, you're trying to figure out, all right, well, which is the potential antidote, which are not the antidote, and I want to make sure that I'm keeping the one that I think is the antidote. The last thing you can do is use what's called a syringe card, which allows you to exchange this particular card for some other card that another player has already discarded. So it could be a face-up card, or it could be a face-down card like that. So you usually only get 1 or 2 of those, so you want to handle those very judiciously and be careful about when you use them as you need that kind of important information. So at the end of the game, you'll be left with a single card like this, and you'll flip this over, and if it matches, so if this were to match, it does not, it's the green one there. If it doesn't match, then you die. If it matches, and you have multiple people who match, whoever has the highest number card in that color is the winner. So in this case, if I had this card, this is only a number 2, so it's fairly low. If somebody else had the same thing, but at a higher number, then they would kind of win that round. So that's how the game is played. There are a variety of different kinds of expansions that come with it as well, such as the Lab Romance expansion. So this one basically changes the objectives of the game based on the kinds of cards you draw. Maybe you want everybody to survive, maybe you want just one or two other people to survive, maybe you want everybody to take the wrong thing. And so that kind of changes your approach to the game. But essentially it's a deduction and hand management, trying to figure out what's the right antidote and hanging on to the right cards in order to survive at the end. So that's a little bit about how the game is played. Let's talk a little bit about some of the science behind this one. So that's a little bit about how the game is played. So what about the science? So this game is loosely based on a sciencey theme. It's definitely clearly more of a deduction game, and I think you could get along just fine by kind of removing all the sciencey aspects of it and replacing it with something else. There's sciencey-ish type language, but the theme is fairly light on this one. So for example, some of the kinds of drugs that are potential antidotes, so one of them is Agent U. So that's probably a take on or a knockoff of the Agent Orange, which was a really bad poison. There's also another one called Rubiximab, which sounds somewhat similar to an anti-cancer drug, a real one called Rituximab, sometimes sold under the name Rituxan. There's also one called C9, and there's a fairly dangerous synthetic drug out there called Cloud9, a synthetic designer drug. So it's kind of sciencey adjacent, but not quite spot on. So one of the potential antidotes is called Boothide, and that's actually that's not a real thing at all. It's based on the name of one of the backers, whose last name is Booth, and they got to name one of the drugs, and so they named it after them. So it's reminiscent of it. It sounds sciencey, but there's actually not a huge amount of science behind it. So let's talk about the premise of the whole thing, this idea of breaking a glass bottle in a lab that releases an airborne toxin, and you only have 30 minutes to take the antidote. This is a stretch. This is a pretty significant stretch. So first of all, a couple of things. Toxicity, almost anything can be toxic at high levels. So common things like carbon dioxide that's in the air that we breathe, that's not toxic for us at normal levels. But if that's all you breathe and there's no oxygen in the air you breathe, it could eventually kill you. There are other kinds of toxins like carbon monoxide poisoning that you frequently hear about with things like car exhaust or things like that can kill you. So those kinds of things could potentially be found in a lab, but a lot of time, so let's say even a giant canister of carbon dioxide gets released, it's not going to be at a concentration that's going to do you any harm. You can just hold your breath and leave the lab. So that's not super realistic. There are some kinds of gases, some aerosolized toxins and poisons that are really deadly, even at somewhat low concentrations. So there's things like chlorine gas, which can be really bad, phosgene and mustard gas, some things that have been used in kind of chemical and biological warfare, hydrogen cyanide. But a lot of these drugs too, the antidotes or the ways they're treated are through intravenous treatment. So not through just chugging a random bottle of green fluid. That seems really safe to me. So there are a few kinds of things that are, let's say, odorless and powderless and tasteless. Some things like iocane powder that are really, really deadly and among the more deadly toxins known to mankind. There are some things like compound 1080, which is a sodium fluoroacetate, that are really, really bad. And there's a couple of other pretty serious aerosolized toxins like sarin gas. Mercury, if it's aerosolized, can be really nasty. Ricin. Anthrax is a bacterial toxin that can be aerosolized. But again, if you're working with anything like that, I mean, sarin gas, for example, is 20 times, perhaps even more, 20 times stronger than things like cyanide poisoning. And you've got anywhere from like 1 to 10 minutes on a high dose of sarin gas before you're deceased with something like that. But those kinds of toxins are not just going to be sitting around in a glass jar in a lab. And so this kind of scenario is pretty unrealistic in that sense. Anything that's going to be aerosolized, and that means you inhalant, that means you would breathe it in, and kill you in 30 minutes, you're going to be working in a BSL level 4 lab or something like that. BSL is biosafety lab. So you're talking about massive amounts of equipment and external oxygen supply to keep people safe. The biggest danger there is probably not from exposure to all the people in the lab, but through like a leak or cut in your suit or something like that. So anything that's that dangerous is probably going to be worked on in a really, really in a situation where this just is not going to happen. If I could be so bold, I would say perhaps a better version of this, I mean, it's still a bit of a stretch, would be something like a snake bite or a spider bite or something like that. That's probably more likely to kind of occur naturally, or something where you're like, all right, I've got to scramble and find this antidote relatively quickly. I'm on a bit of a timeline, that kind of thing. So the science theme here, it's sort of an add-on. It sounds good. The words sound really cool to talk about, but hopefully none of you will ever run into a situation like this. So it's kind of a stretch here, and it doesn't really work in terms of the real science. But there are some toxins out there that are really dangerous. It's just that you're probably never going to be exposed to them, hopefully, for sure. So anyway, it's an interesting game. You don't see a lot of science games that are in the kind of social deduction realm, so I appreciate that contribution to this. So hopefully you've enjoyed this and enjoyed talking about this, and this has intrigued you. And I look forward to sharing some more with you here in the future.